So I gave students 2 minutes on page 24. I finished a lot of general announcements. There was a lot to summarize because right now students have 2 more days to retake CFU 1. They just got CFU a week to retake that, and CFU 3 is going to be this week in 2 days on Thursday. I also just mentioned that we have a test that is not reassessable next week on Friday. That'll cover everything in this note packet. So you are responsible for understanding how to do everything on CFU 1, 2, and 3 if you want to do well on that test. Okay? Students, again, we're already given time on page 24, and we're going to start with our Algebra 1 skills here. Okay? Recording. All right, so thank you to those of you who contributed here. Again, just repeating myself, part A, you get rid of the positive 4 by subtracting 4. In part B, you get rid of positive 11 by subtracting 11. And that gets you to 5x equals 30. And when I say 5x, I mean it's 5 times x. So the way you get rid of that 5 is you do the opposite. You divide by 5. Notice again what's in green and what's in blue. For the first equation, you can just do that in your head. It's 1 step. Subtract 4, you're done. Just write the answer, x equals 12. But with the other one, it's 2 steps. I want to see some of the work. So I'm not going to require you to show me the minus 11, but I want to see the 5x equals 30. I'm not going to require you to show me the divided by 5, but of course I want to see x equals 6. Okay? Now the next 2 equations, they have extra little things that make them a little more difficult. Okay? So with C, I'm going to show you 2 different ways of doing this. I'm going to start with my preferred method. And I'm going to tell you right now that the thing that trips people up the most is they don't, and I mean even adults, not just you all, adults don't seem to understand that when you see a fraction like 6 over 5, what it really means is times 6 divided by 5. That's what it means. Okay, so I'm hoping we're all at a point where we all understand if you want to get rid of the positive 16, the opposite of that is you subtract 16. But the thing that's maybe not so comfortable is how do you get rid of the 6 over 5? And my opinion is to understand how to get rid of that, you have to understand that 6 over 5 means times 5 divided by 5. So to get rid of it, you do the opposite. You multiply by 5 and you divide by 6. Okay, and that's sort of my preferred method here. So what I did on both sides was I subtracted 16 from both sides. Okay, Mr. Fee, we got an empty desk up front for that gentleman. That's his. So I subtracted 16 from both sides. That got me here. Now I know that 6 divided by 4 it's times 6 divided by 5. So to get rid of the 5, I'm going to multiply by 5. And if you think about it, this is kind of like saying 6 divided by 5 times 5. Well, if you do 6 divided by 5 times 5, the 5's just go away, and you're left with the 6. And over here, you've got 12 times 5 is 60. And now you've got 6 times x is 60, so to get rid of the times x, you would divide both sides by 6, and then that gets you 10. Now, I mentioned I was going to show you 2 different ways, because this is my preferred method. But here's the other method. Bless you. I see plenty of people, they want to convert the 6 over 5 to a decimal. I have no problem with that. If you want to do this, 6 divided by 5 is 1.2. If you want to change that fraction to the decimal, no problem. Here's what happens. You're still going to subtract 16, okay? But after you subtract 16, instead of writing 6 over 5x equals 12, you can say, well, 6 over 5 is 1.2. You can write 1.2x equals 12. And now you have one number to divide away. Divide both sides by 1.2. That's going to get you the exact same answer. Now, the reason, I'm sure many of you might be saying, well, I like that way. That kind of gets rid of the whole confusing thing with the fraction. But the only reason I don't prefer this method myself is because sometimes fractions are really ugly. You know, like if you were trying to get rid of the fraction 7 over 8, you got to get rid of that fraction. And it's like, even that's not all that bad. But what if it's 8 over 7? Now you're trying to get rid of that thing. It's like, I don't want to have to write that down. So again, my preferred method is, if I'm trying to get rid of 8 over 7, I'm just going to do the opposite. I'm going to multiply by 7. I'm going to divide by 8, and it gets rid of it. Sir. So the question was, if I want to use this decimal value, and I use a rounded version, would you get the wrong answer? It's not going to get you the wrong answer, but it's going to get you a value that you would also need to round. So it brings into it a situation where I'm not going to mark you wrong if the answer is 6 and you write 6.001, but it can make it more complicated. All right. Now, that one I said was a little trickier because it has the fraction. The next one, in my opinion, a little bit trickier because it has a variable, an extra variable, but that doesn't change anything. If your goal with example D is to get x by itself, you basically treat it the way we've been treating all the other problems. You would add y to both sides, and that, again, I'm going to challenge you to kind of picture that in your head. If you add y to both sides, then over here you just have 2x. Over here you have y and 16 being added together. And so the only other step you have left to get x by itself is to divide by 2. So even though you have a second variable, the process doesn't change at all. If you want to get x by itself, get rid of the y by adding it to the other side, and then divide both sides by 2 to get x by itself. There's absolutely nothing wrong with that. Okay, this again, by the way, is what homework number 5 was focused on, your background Algebra 1 skills. Go ahead and turn the page. As I said, the next thing is we're going to practice a couple problems that are identical, like very, very similar to what we ended last class with. Okay, last class was about introducing the concept of inverse functions. Okay, now that's what's summarized at the top of the page. Recall, so you should remember this from last class. Functions which undo each other are referred to as inverse functions. This means if you put a number through a function, then plug the resulting number into its inverse function, you should have the same number you started with. Here's what that's basically saying. If I give you a function and I tell you, plug a number into it, plug a into that function, the function will take a and it will turn it into another number. So the function takes a, turns it into b. Well, if you then take b and plug b into the inverse function, the whole idea is that when you plug b into the inverse function, it gets you right back to the value you started with. That is the nature of inverse functions. The function turns an a into b, the inverse function turns b right back into a. And this is kind of what we ended class on yesterday. Now I'm going to do one example. I'm going to ask you all to do one right after me. Okay, problem 2 says plug the given value into the f of x function, write the answer in the result, then plug that answer into g of x, and write the answer in the end box. Now, if you truly understand the way this is supposed to work, you can kind of cheat the system a little bit, take the 5, and just write it in over here. Because that's what's supposed to happen. You plug 5 into a function, it does something to it, it turns it into some other number, and then the inverse function turns it right back into 5. Now, I'll tell you on our CFU Thursday, there's going to be stuff on this. I'm going to be testing you on your understanding of inverse functions. That's what's going to happen this Thursday. This is a great way to get a free point. Just take that number, copy it in the end box. You're not going to get full credit, though, unless I see the work. So I want to see that you take this number and plug it in here. So I'm going to rewrite this equation, but instead of writing x, I'm going to write 5. So 5 divided by 5. Now, you all help me out with the math. What is 5 minus 15? Not just 10, negative 10. That's important. 5 minus 15 is negative 10. Now, what is negative 10 divided by 5? Remember, it's just 10 divided by 5, but with a negative attached to it. Negative 2. Negative 2. So the function turned 5 into negative 2. That is our first result. Now what I'm going to do is take negative 2, and I'm going to plug it into the inverse function. So now I'm going to copy this equation, but instead of writing x, I'm going to write negative 2. That's the idea. So 5 times negative 2 plus 15. Now, what is 5 times negative 2? Remember, it's 5 times 2 with a negative. Negative. Oh, no, not negative 15. Negative 10. 5 times negative 2 is negative 10. And what is negative 10 plus 15? Not negative 25. Huh? So if they were both negative, if it was negative 10 minus 15, then you get negative 25. But it's negative 10 plus 15. Yep. 5, which is exactly what we were expecting to get. Okay? That's the whole idea. The function turned 5 into -2. Inverse function does the opposite. It turns -2 back into 5. All right, take 2 minutes and do the next line yourselves, folks. And again, if all you do is copy that first number 2 into the end box, yeah, you're going to get a point, but you're going to miss out on the other 2 or 3 points because you have to be able to show me the work. Okay, go. Okay, so I asked Kayla, she said I got 9 in the middle, but again, if this is the only thing you on your CFU on, you got it. So I'm going to copy this equation, but instead of writing x, I'm going to write 2. So I'm going to write 2 squared plus 5. I'm going to please beg you all to push yourselves to do mental math. I know you want to use a calculator. A lot of folks might want to use a calculator, but I'm telling you, if you don't force yourself to do mental math, you're never going to get better at it. 2 squared just means 2 times 2, which is 4, and 4 plus 5 is 9. That's where that came from. So the function turned 2 into 9. We're now going to take 9, plug it in over here. So I'm going to write square root of x minus 5, but instead of x, I'm going to write 9. 9 minus 5 is 4. And again, feel free to use the calculator. The square root symbol is hidden underneath the x squared key, but it's blue, so I hit the blue button first, then the x squared button first. Feel free to do this if you'd like, okay? Or you could do the 9 minus 5 is 4 and do it that way. But the reason the square root of 4 is 2 is because 2 times 2 is 4. And that confirms that we did this correctly. All right, I'm going to do the third one very quickly here because this is, again, this is practice of what we ended last class on. I want to get to the new idea for today, which is very much related. It's not like a brand new concept. All right, so I'm going to rewrite f of x, but I'm going to write -9 for x. Okay, so notice I did 3x plus 7, but instead of writing x, I wrote -9. 3 times -9 is -27. Plus 7 is -20. So the function turned -9 into -20. Now I'm going to take this -20 and I'm going to rewrite this equation. But instead of x, I'm going to write -20. Now, this is where a lot of people might make a mistake if you're depending on the calculator. Let me make something very clear here. If you do -20 minus 7, you get -27. And -27 divided by 3 is -9. So it absolutely is supposed to work. Check this out. If you're going to depend on the calculator for fractions, let me be clear here because I'm telling you this is going to mess a lot of you up if you're still depending on the calculator. If you're going to do something like this fraction in a calculator, you must put the top in parentheses. I'll show you what I'm talking about. If you want to do -20 minus 7 divided by 3, you have to put the top in parentheses. This will get me -9. If I don't put parentheses, that's going to get me -22.33333333. It's a completely different number, and it's totally wrong. If you type it like this, the calculator understands PEMDAS. The calculator knows division comes before subtraction. So if you type it like this, what the calculator is actually doing is it's going to divide the 7 by 3 first, and then it's going to do -20 minus that 2.333333 number. And that's wrong. We don't want it doing that. We don't want it to 7 by and subtract it. We want it to do the subtraction first and then divide. So again, if you're going to use the calculator for things like this, you must put the top in parentheses. Otherwise, the order of operations in the calculator will get messed up. Questions? So now let me give you a brief summary on the new thing. Those are like the only new thing we're doing today. In every single example we've done so far, I have given you the function and the inverse function. The new thing that I'm going to try to show you next is what if I give you this, but I don't give you that? Okay? What if I give you this, but I don't give you that? What if I give you this, but I don't give you that? This is the new thing I want to teach you now. I want to teach you that if I give you a function, if I tell you, look at the orange highlighted one. If I tell you I've got a number, I'm going to subtract 15 from it, and then I'm going to divide that whole thing by 5. So I give you that equation. I need to be able to ask you what is the inverse function, and you have to be able to give me that. If you focus on the green equation, so if I tell you I'm thinking of a number, I'm going to square that number, so x squared, and then I'm going to add 5 to it. So I tell you what the function is, and then I ask you what's the inverse function. You have to be able to get me that. That's the new thing I want to show you. Now, I promise you it probably sounds way scarier or more intimidating than it needs to be. It's actually, the process I'm going to show you is really straightforward. Okay, here we go. So the flow on this page is, I'm going to give you a function. We're going to use it to calculate a number. We're then going to write the inverse function, and then we're going to make sure we have the right function by doing the opposite calculation. Okay? Let me show you what I mean. So the steps listed below are a description of the function f of x when given a value x. So let's say we're thinking of a number x, and I tell you add 5 to it. So write x plus 5, please. I then tell you multiply that quantity. Now that's a fancy word, but anytime you hear quantity, just think parentheses. So multiply that quantity by 3. So we took x, we added 5 to it. Now we're going to multiply this whole thing by 3. And then the third step is finally subtract 6. So I gave you the equation, but I didn't give you the inverse. Now we're going to use this equation, and then we're going to try to create the inverse. Okay, this says use your equation from part A to find f of 7. So I'm going to plug 7 in for that x. So it's 3 times 7 plus 5 minus 6. Now let's see if I have anyone brave enough with their mental math. Don't touch a calculator, folks. Remember, parentheses come first. What is 7 plus 5? Somebody said it. 12. 7 plus 5 is 12. Now we have to do 12 times 3. Now, when I do 12 times 3, bear with me here for a moment. When I'm doing 12 times 3, I don't do 12 times 3. I break up the 12 as 10 and 2. I find it's a lot easier to do it in parts. This does require what I like to call mental math memory. You have to be able to hold numbers in your head. If I'm doing 12 times 3, I don't do that. I break up the 12 as 10 and 2. I'm going to multiply each of these by 3, and then I'll put it back together. To me, I find that a lot easier, because 10 times 3 is 30, 2 times 3 is 6, and when you put them back together, you get 36. That's what 12 times 3 is. Okay? And then what's 36 minus 6? 30. Okay, so we were given instructions. We used it to write a function. Then we used that function to turn 7 into 30. Now we're going to create the inverse function ourselves. And the way we're going to test it is we're going to make sure it turns 30 back into 7. Does that make sense? Okay, but I need to teach you how to write the inverse. Sounds fancy. It's really not that bad at all. Okay, here's how you do it. Given x, write the steps of f inverse using the opposite operations in reverse order from before. So here's the deal. Instead of adding 5 first, we're going to do the complete opposite. Opposite of adding 5 is subtracting 5. And instead of doing it first, we're going to do it last. So take add 5 and subtract 5 at the bottom. Instead of it being the first step, it becomes the last step. Now, the last step was subtract 6. We're going to completely flip that. That last step of subtract 6, it's going to become the first step, but it's also going to flip. Instead of subtracting 6, we're going to add 6. That's going to be our first step. This is how you create an inverse function. And the step in the middle, it actually stays where it is, because if you think about it, if you take steps 1, 2, 3 and reverse them, 3, 2, 1, 2 is still kind of in the middle. But remember, multiply turns into divide. You still have to do the opposite. Okay, so the middle becomes divide that quantity by 3. So if you have a function that says add 5, multiply by 3, subtract 6, the inverse function does those exact same things, but opposite and in reverse order. So add 6, divide by 3, and then subtract 5. So watch this. I'm going to write out the inverse function now. I'm thinking of a number, x. I'm now going to follow our new steps that we created. I'm going to add 6. I'm going to divide that quantity by 3. Remember, quantity in parentheses. So I'm going to put parentheses around this whole thing, divide it by 3. And then I'm going to subtract 5. My claim is that is the inverse function. And the way we're going to test it, the way we're going to know we did this correct, is we already know the function turns 7 into 30. So if this really is the inverse function, it better turn 30 into 7. So I'm going to test it. I'm going to rewrite this. This is the directions for E. It says take the value found in part B. That was the number 30. Plug it into the function. So I'm going to rewrite this function, but instead of x, I'm going to write 30. And now I'm going to solve this. And I'm crossing my fingers saying, I really hope this gets me 7. So 30 plus 6 is 36. Forgive me, I am going to do the mental math kind of quickly because we only have about 5 minutes left. 30 plus 6 is 36. Divided by 3 is 12. And 12 minus 5 is 7. And if your answer to part D is correct, what value should we get in part E? We should have gotten 7, because you should end exactly where you started. The function turns 7 into 30, so if we really did a good job of creating the inverse, it better turn 30 back into 7. Go ahead and turn the page for the last time today. On this next page, we're going to look at the exact same idea. I'm going to give you a function. We're going to use it to do a calculation. We're going to write the inverse, and then we're going to make sure it's the inverse by doing the opposite. Okay? Yes, sir. All right. So I'm going to go through this kind of quickly because, again, Mr. Fee is pointing out we have about 4 minutes, and I want to use 2 of those. That way I give you 2 to pack up. So I'm going to start with x. I'm going to subtract 2. I'm going to take the square root of the quantity. It doesn't say square, because square is the opposite. Square root and square root are opposites. It says square root, and then add 7. So that is the function. Now it says plug 18 into this. So I'm going to rewrite that using the number 18. Now, again, I'm doing the mental math kind of fast today just because I want to make sure we get through it. 18 minus 2 is 16. Square root of 16 is 4. And 4 plus 7 is 11. So the function turned 18 into 11. So we're going to write the inverse function, and then we're going to check it by making sure it turns 11 back into 18. Now, again, all you do to write it is take these exact same steps, put them in reverse order, and flip them. So instead of subtracting 2 first, we're going to add 2 last. Instead of adding 7 first, we're going to subtract, or excuse me, instead of adding 7 last, we're going to subtract 7 first. And instead of taking the square root, we're going to square. For those of you packing up, I'd appreciate it if you stop. As I said, I'm going to get you 2 minutes to pack up. Okay, we should still be taking notes, folks. So I'm going to start with a number. I'm going to subtract 7. I'm going to square that quantity and then add 2. And now I'm going to take the number that we got in part D. Remember, in part B, it turned 18 into 11. So I want to make sure 11 turns into 18. Well, 11 minus 7 is 4. 4 squared is 16. And 16 plus 2 is 18. So if my answers for either D or E were wrong, I would know if I don't get 18. We started with 18, it got us to 11. 11 should get us back to 18. So if you don't get back to 18 here, you know you messed up. You screwed up something. Okay? All right. Thank you for your patience, folks. I know I kind of pushed really fast in those last 8 minutes or so, but we will practice this more tomorrow. Okay? All right, so it was my fault that that last bit of class was a little bit rushed. My apologies for that. I did tell the classes that I would post within this video the starting point of homework number 6. So it can look incredibly intimidating. I go one step at a time. Remember that that first step says multiply. Then it says subtract 8. Then it says square that quantity. And remember, quantity means parenthesis. So whole thing, and I'm going to square it. Then it says divide the square of the quantity. So divide the whole mess by 4. And finally, add 13. So that is what the equation looks like for homework number 6. Okay, now the flow of this problem, that to me is the hard part, like just getting that initial equation written down. But then the flow of the page is just like what we did in class. You're going to plug in 24, that's going to get you a number. You're going to reverse the steps to write the inverse, and then you're going to use the inverse to make sure it gets you back to 24. Okay? In fact, I'll just go ahead and show it that if you plug in 24, you're going to get 38. So once you write out the inverse, and you get that equation, the whole idea is to prove that it's the inverse or to check that it's the inverse, you would plug in 38 and make sure it gets you back to 24. All right. Thanks for watching. Have a good one.